Hello again, everyone. We are going to talk about the methods by which charge can be transferred today. And this involves the insulators and conductors. You may have heard of these terms before. It has to do with how well certain objects receive or give charge. In general, a conductor is going to be something that accepts charge easily, or rather transfers charge either to itself or from itself easily, while an insulator is something that is very poor at conducting electric charge. Some good examples of conductors are any types of metal, and some common examples of conductors, otherwise known as insulators, are things like rubber, wood. These things don't conduct electricity very well, as I'm sure you're already aware. Um, just keep in mind that when we talk about charge transfer, we're really talking about electrons. Remember, the protons do not leave the nucleus of atoms. This is a nice picture of just showing us good conductors versus good insulators. So everything on the left side conducts electricity well. Everything on the left side here does not accept the flow of charge easily. You need a lot of energy to force charge onto something like rubber or plastic or wood. Obviously, you can go through this a little slowly if you prefer. I'm just kind of carrying you through to give you a little bit of extra info when I can. Now, the way we can actually force charge upon materials in one way is called conduction. This is charge by contact. The way conduction works is you take an object that already has charge and you kind of force that charge onto another object, either by direct contact or by forcibly rubbing that charged object onto the object in question you're interested in. Now, the method of charge by induction is known as charging an object by proximity, but there's a little nuance here. The object in question when we're dealing with induction is not really getting charged, and you're about to see. I'm going to show you a picture. But again, with induction, we take an object that's already charged and we bring it close to an object that we're interested in. Now, this bringing close doesn't actually charge the object in question, but it does redistribute the charge within that object. Again, I'm going to show you a picture here to illustrate this a little better. So let's say we have a positively charged object. We could accomplish this positively charged like stick. You can do this by just taking like maybe like a plastic rod and rubbing plastic wrap on it. You bring that near, let's say, a neutral object, and we actually make contact. Well, what's going to happen is the excess positive charge is going to say to the electrons in this neutral block, hey, we're going to jump over here and transfer. So now this positive object on the right is going to gain a little bit of electrons, and this originally neutral block will now be positively charged. And so therefore, this object is the one in question, the metal block. This is now a positively charged object. Here's another picture of conduction. If we have, this is called an electroscope. You'll see this again soon. Positive object touches the top of the sphere of a neutral object, and now the electrons jump into the to the metal rod, and the object in question is now positively charged. Now, induction is that charge by proximity I mentioned before. So same situation, a neutral object. This is what we're interested in. We're trying to charge this object. We bring that same positive stick close to it, but we don't touch. So it's not enough for the electrons to jump onto that object, but they do redistribute. In other words, more electrons are brought to the right side of this object, and the left side now has an excess of protons. Now, they haven't left the object, so it's still neutral, but we have kind of polarized the object in the sense that now the right side is negative and the left side is positive. So induction doesn't really charge objects, but it just redistributes the charge overall to different parts of the object. And again, here's your picture of induction. This sphere is neutral, that is no overall charge, but one side is much more charged than the other due to the presence